Hello, my name is Yu. I'm representing our team for presenting our practicum project, which is building a machine learning application for diagnosing chest X-rays with biases in mind. Here's the outline of this project, and we have two primary goals for this project. One is using machine learning approach to build a model that has a reasonably good accuracy for automated disease diagnosis. In this case, we choose to look at pneumonia based on chest X-ray images. Second is demonstrate the use of this machine learning model by designing and building a smart on-fire web app that utilizes this model in a medical context. And you will see the details of this app during the demonstration stage. Here's our team composition and our contributions. Each of us actually have taken multiple roles and collaborated really closely to make sure we deliver this project. We have done extensive research for this project from multiple angles, from industry point of view, from the gaps in domain point of view, as well as interviewing some end users. We have four parts here. Elaine is going to give an overview of the Smart on Fire user interface, also highlight the ability of the pneumonia detection feature. And James will talk about how the front end invokes the SageMaker model, the connection part. Anish will talk about the back end, how it actually works, and I will give a quick demo of the functionality of the front end. So with this, I'm going to click on the launcher and give it to Elaine. Can you see it, Elaine?
Yep, and then we'll just log in to the Smart App Launcher. We've utilized this in other assignments as well, kind of simulates the EHR, electronic health record. So we'll log in as a provider because the provider will be the individual who is able to upload the X-ray under the patient profile. So if you want to go ahead and launch the app. Perfect. So we'll log in as Dr. Orn right there. And then we'll select the patient Mariana Acuna. So under her profile, we decided to implement our application on the same page as her other data and medical statistics, such as height, weight, blood pressure, etc., as well as her medication here. So that way, when you upload the chest X-ray and you get the feedback of whether or not Mariana has pneumonia, you also have her other information there to see in one place. So that way, it makes it easier for the physician to get a better understanding of the patient's entire picture. And as you can see there, we also have the upload image ability inside of the EHR itself. So we're trying to keep everything in one place to really improve simplicity and visibility for the provider. And then James, if you want to talk about how we are interfacing with the machine learning model through our application here.
Once a provider uploads an X-ray image to our portal, the front end makes two requests to receive a prediction from the machine learning model that we built. The first request processes the image uploaded by the provider and uploads that image to a public S3 bucket. In a real-world application, we wouldn't make this bucket public. To keep the project configuration simple, we've allowed public access to the bucket. The second request is made to Amazon's API gateway in order to invoke the SageMaker model. This request returns a prediction from the model, which is then displayed to the provider under the prediction results section. I will hand it off to Arnesh to talk about how the backend works.
Just to start off, this application diagram kind of shows how our project is set up. So first we have the app, which is the Smart on Fire application, and then it's communicating with these three components here. So these are all hosted in AWS, and the first is our API gateway, which is then connected to our Lambda function. And our Lambda function is responsible for communicating back and forth between our machine learning model, which is hosted in Amazon SageMaker. So I'll be covering these three in kind of reverse order. So I'll start off with the model, then I'll cover the Lambda function, and then the API gateway. So this is Amazon SageMaker. I'm in the AWS Management Console, and this is the notebook instance that we use to train our machine learning model. So I'll open up the training Jupyter notebook, and here you can see this is the script that we use to train our model. We used an estimator, which takes in an entry point, which contains the code for training our model, and then some additional parameters such as the number of epochs, batch size, and then it kind of starts off the training process, right? So here you can see all of the messages related to our model training, and at the very end, once all of our epochs were completed, you can see that model training was successful and we have a trained model. So once our model was successfully trained, we deploy that estimator to an endpoint, and that endpoint is available here. And this will be important, especially when we go to the Lambda function, and that's how our Lambda function knows how to communicate with this model endpoint. After that, I just did some model testing. I won't cover this too much in detail since it's located in our README file, but just to give you context on the results, our precision was at 70% roughly, and our recall was right around 99%. So in this context of predicting if patients have pneumonia or if they don't, we want to minimize the number of false negatives, which means marking patients that do have pneumonia as not having pneumonia. So we want to minimize that. And for that purpose, we care most about recall. And our recall was particularly high for this model, which is what we wanted. So that was a particularly promising sign from our model. And then we just ran through two example images, one for a patient without pneumonia, one for a patient with pneumonia, and the model was able to make predictions on them successfully. So once we had our model trained, and just to cover the model architecture, we trained a convolutional neural network with 5 layers, all with batch normalization applied. We had 2 fully connected layers and then dropouts set to 50%. So that's just to give you context on the architecture we used. And again, the README covers this more in depth. Going back to the management console, to Lambda, this is the Lambda function that we used, and this essentially takes in an event. So this is from the Smart on Fire application, the image that is uploaded to S3, it takes in that S3 URL, parses it out using the URL lib library, and then takes that image and passes it as a byte array to our model endpoint, which is the same address here as we had in the Jupyter Notebook. Once we invoke our endpoint, then we get a result, which we save as response. We parse that out, read it, and then we're applying an argmax to that result since it's an array, and then essentially that result is going to be either a 0 or 1. 1 corresponds to pneumonia, 0 corresponds to normal. So then we just pass back the object categories array with that index passed in. So we get the either normal or pneumonia result passed back. And we're just passing that back as our body. So that's our Lambda function. And then from here, we also have to configure the API gateway. So if I click on under services, API gateway, we can see the X-ray classification API, and we configured a post method since the Smart on Fire application is posting to this API, and we set it up with integration type for Lambda function using Lambda proxy integration, and the Lambda function is just passed in here as the name. So that covers the AWS portion, which comprises a majority of the backend, and again, a lot more details are available in this README that we have for our project here.
And here I'm going to give you a quick demonstration of how this chest pneumonia detection module of the app works. So if we go to Browse, we find a local picture here. And here I already have 3 files for my demonstration purpose. And I'm going to pick one that we know does not have pneumonia and named normal. In this case, once I open it, the app actually gave a preview of the image. And this helps the doctor to figure out if, give a very direct view of if it's a desired image that the doctor is uploading. And when we press submit, the prediction result changed to normal based on the model. And if we want to do another image, we remove this image first. And we browse again. We pick a one with pneumonia. And we do submit and actually predict to have pneumonia. So I want to show another feature that we actually embedded into this app is if the doctor accidentally upload a non-image file, like the txt file in this case, we actually will show an alert saying, please click on remove image button and upload a JPEG or PNG image. So this gives a nice reminder of the format of the file that need to be uploaded here. We click OK and we can remove the image here. So that's for the upload and prediction functionality. We also have the annotation functionality here, although right now it's not integrated with the EHR system because we do not have the currently the sandboxes does not have that resources image resources linked. But we can have it for future as we talk about on the presentation slides. For example, I can add a note here saying patient complaints of short of breath at. It shows the author who made the annotation, the time this note was made, and what is note message here. And this can be a nice functionality to be integrated with the image so that for later review purposes. And today, we have been able to build an accurate machine learning model that can predict whether the patient has pneumonia or not based on an uploaded chest X-ray image. And with the model precision of 0.7 and the recall of 0.995. And the Smart on Fire app has been successfully built and deployed that displays a snapshot of this patient key profile with pneumonia prediction feature. For future, we could expand the prediction capability of the model from binary to a multi-class so that multiple diseases can be identified based on the modeling. We could also further integrate the features of the app with the EHR system, such as the image upload and annotation features, and also broaden the application of image-based machine learning modeling for other medical applications beyond chest diseases. With this, we'd like to thank you for your support and the mentoring for this project and this course. Thank you very much.